In the previous class, we have discussed about the NOR gate in gate level modeling. Today in this class, we are going to discuss about the NOR gate in Dataflow modeling. So, if you are if you haven't watched my previous videos, I recommend you guys to watch those previous videos. Why? Because I'm not going to discuss about the test bench, how I have written a test bench. So, I recommend you guys to watch the videos from the NOR gate itself. Or if you don't have time, I recommend you guys to watch the previous video to know the uh, how this particular test bench is written and how this gate level modeling code of NOR gate is written. So today in this class we are going to discuss about the data flow model. So without any delay, let's move into the video. So and also in each and every design starting, when I'm going to design it in gate level modeling, I am going to discuss new points related to the test bench. Okay, new points related to the test bench. You need to observe those points. In Verilog, we mostly focus on the design code so that I'm not focusing on the test bench. But I am going to give you the new points in gate level modeling videos of every design, like NOT gate in gate level modeling and NAND gate in gate level modeling, AND gate in gate level modeling, and now NOR gate in gate level modeling videos. I am going to discuss the uh, how to write the TB, and also I am going to discuss several new points in those lectures. I recommend you guys to watch those lectures if you want the TB. Okay, and I also recommend you guys to watch the switch level modelings, which nobody have discussed. Uh, okay, switch level modeling is very important. Important in the sense it is important to know. Okay, yeah, there is a switch level modeling. We can write like this. Okay, even if you know know how to write for just these gates, these universal basic and then um, arithmetic gates, then that's enough. Okay, switch level modeling, okay, that's more than enough. Okay, without any delay, let's move on the video. So this is the gate level modeling code, right? I am going to change it to data flow model. Let me change the comment first. Later in every videos I am going to discuss it, right? Module name and the port list and then end module, everything will be same for any level of abstraction you are going to take it, whether it may be the gate level model or the data flow model or the behavioral model or the switch level model. Only the matter in between the semicolon and the end model is going to change. Let me remove this matter. And since now we are going to write in the data flow model, we are going to use the assign keyword in the data flow model, which is for continuous assignment statements. Assign y is equal to, we are going to assign y with a value. Okay, means we are going to drive the y, output y with a value, that is NOR gate, right? We need to give the NOR gate expression, right? We need to know about the Boolean expression of NOR gate. What is the Boolean expression of NOR gate? It is nothing but a plus b whole bar, right? So it is nothing but a plus b whole bar. A or b whole bar. A or for this operation whole bar, right? So the single straight line is indicate it is going to indicate the bitwise OR operation between A and B. For the whole result, since we have placed the whole thing in the parenthesis, for the whole result we are going to perform the NOT operation, then we are going to get the NOR gate functionality. This is how we are going to write the code in data flow model. Okay, so the TB, you shouldn't need to change any of these details in the TB. Okay, if you are going to replace the module name in TB, sorry, if you are going to replace the module name in the design, then you need to change the instance name which you have instantiated the module in the TB to the same name. Okay, like this. Other than that, there is no need to change the TB. For all levels of abstraction, the same TB can be used. Okay, and I am not going to focus mostly on the TB as I discussed. I am going to focus mostly on the design code in Verilog. Okay, after writing the design code and the test bench, we just select the tools and simulator. Go to tools and simulator and select the first tool, and then save the code and run it. There is an error. Yeah, I haven't put the semicolon. Okay, I haven't given semicolon over here. Just to give it and then run it. Every statement in the Verilog will be ended with the semicolon like it is in C programming language. So you can see the output right in the console. At after 0 nanoseconds point of time, we have applied our inputs test cases as p is equal to 0 and q is equal to 0, and we are going to get output test cases r is equal to 1. For all other cases after the specified time, we are going to get the output test case as 0. Okay, this particular operation we can able to observe in our NOR gate, right? We are going to able to observe this particular operation in our NOR gate. So we can able to say that our design code is functionally correct and it is going to work as a NOR gate. Next, now if you want to see the output in waveform, okay, there are two ways of seeing the output. One is using the log file and also other is using the waveform. For that you need to include the two lines. These two lines you need to include. Okay, for seeing the output in the console you need to use the dollar monitor or the dollar display or dollar strobe. There are so many. Okay, with minute differences in between them. Okay, we generally use dollar monitor, and why we are going to use, I have discussed very clearly in the test bench explanation videos. Okay, of you watch the gate level modeling video. Okay, of every design I am going to discuss in that video. I am going to discuss about the test bench. Now if I am going to discuss here, the video length will be very more and you will get very bored. Okay, so I'm not going to discuss over here. And most of the people gave me a complaint that, sir, your videos lectures are very high duration, so that I am not going to explain those points here. Okay, so open EP, and what you guys need to do is you need to check whether these two lines are available in your code or not. Later you need to click on open EPWave after run and then save the code. It shouldn't appear star mark over here. Just save the code. See, the code is saved, so that the star mark over here is disabled. Run the code. When you are going to run the code, then what happens is you are going to get the pop-up of waveform automatically. Okay, now you can see the input test cases and the output test cases which are used in the TB. For the input test cases, both 0 we are going to get output test case as 1. For all other cases, if you are going to see, we are going to get output as 0. So how to analyze these waveforms also I have clearly discussed in that video. Okay, you just check it. If you already know how to see the waveforms, then no problem. If you are very confused with the timing parameters, okay, then I recommend you guys to watch the test bench video which I have discussed in the gate level modeling of this lecture. Now this is one way of writing in Dataflow modeling for the NOR gate. There is other way also, that is using the ternary operator, ternary or the conditional operator. So you can see the output, right? This is the actual truth table for the NOR gate. So ternary operator is nothing but the simply if else. Okay, so we need to take any one of the condition from the four possible cases of inputs, and we need to use it in the ternary operator. Okay, which one we are going to use is the one condition which is unique, that we are going to use it. The one whose the one input for the one input cases, for the one case you are going to get unique output. For all other cases you are going to get the same output. In this case, for the first case, that is p is equal to 0 and q is equal to 0, we got the r is equal to 1, which is actually unique, right? No other cases uh, got output test cases r is equal to 1, right? all other are all other got r is equal to 0. If you want to use r is equal to 0 condition, then what happens is, in ternary operator you need to specify all these three conditions with the help of the logical and okay. But if you are going to use this first condition, then only this condition you can use it, and all other conditions will be comes under else condition, okay. For example, if you want to write the code in if else, then what you are going to do, either you can specify this case in if, and then r is equal to 0, you will give the statement in the if block, and you simply put the else, and you will give r is equal to 0, right? You are not going to specify all these conditions, right? And the second way is, you need to specify all these three conditions in if by with the help of the logical and between the each condition, and you need to give in if block r is equal to 0, else you will mention the first condition, that is r is equal to 1. Which one is easy? The first case is easy, right? Simply specifying this condition and putting all other conditions in the else is easy to write, and it is correct way to write. We always need to write the code in as simple as possible. As simple as possible in the sense, not in the work, in the writing part. It should look very neat, okay? As simple as yeah, to write code in simple means not to write the code without function, without its function. It means you need to reduce the writing part without changing the functionality, okay. That is the meaning of the simple, okay. So let me use the assign y is equal to, we are going to use the ternary operator, right? So open the braces, we need to specify the condition in this. So whenever our input a is equal to 0, logical, and I am going to use it, and in another input b is equal to 0, then what should happen if this condition is true? That thing we need to specify after this question mark. Our output y should be 1, right? You can see the y is r is 1, okay. This is the test case, this is the input. This don't get confused, okay. You watch the previous video, then you can able to understand, okay. Next, 1 else in the sense, else will be executed whenever this condition is false. Whenever this condition is false is nothing but all other three cases, right? For all other three cases, what should be the output y? That should be 0, right? So like this we need to give, okay. Simple, it's so simple, okay. Now just save the code and run it. Just remove the open EPWave after run, okay. Why? Because let us see the output in the console itself, okay. Why? Because I already explained the waveform in the previous videos, so just I hope you already watched those videos, so that I am going to see the output in just console. So you can see the output, we got the same, right? It means this particular logic also giving us the functionality of the NOR gate, okay. I hope you understood how to write the code for the NOR gate in a Dataflow model using the two ways. One is using directly the Boolean expression, and another is using with the help of the ternary operator by taking one of the condition which is unique among all other, okay. So this is how we are going to write the code for the NOR gate in the Dataflow modeling. Thank you, have a nice day.